People often ask me, when will the universe unveil its next great mystery? My answer is simple, it already has. Somewhere in the cold silence between distant stars, an emissary began its long voyage eons ago. Now, it has entered our cosmic neighborhood, igniting telescopes and imaginations alike. Its name is 3I-ATLAS, a celestial visitor unlike any before, part comet, part enigma, and wholly beyond our expectations. When first detected in July, it appeared no brighter than a whisper of starlight, a faint shimmer easily mistaken for background noise. Yet in mere months, that quiet glimmer has evolved into a dazzling performance of celestial mechanics and plasma physics, unfolding in real time. 3I-ATLAS streaks across our solar system with the raw grace of a dancer made of ice and fire, hurtling toward the sun at nearly 60 kilometers per second, its momentum still building. By late October, during its closest swing perihelion, it will reach a breathtaking 68 kilometers per second, transforming from a silent wanderer into a roaring furnace of light. Imagine it, a fragment of some forgotten solar system plunging through the sun's domain, trailing an emerald glow whose origin defies explanation. Is this the classic signature of carbon reacting to ultraviolet light, the so-called swan bands, or something entirely new, a plasma phenomenon born in the void between stars? But beyond its physics lies something even more profound, a test of humanity's capacity to see, to track, to question, to wonder. From backyard telescopes to interplanetary probes orbiting Mars, our species is orchestrating a symphony of observation, each photon a note in the score of discovery. 3I-ATLAS is not just an object of study, it is a mirror, reflecting our endless curiosity back upon ourselves. As it races toward the sun, it challenges us to follow, not in speed, but in spirit, to chase understanding wherever it hides, even in the spaces between stars. Out there, between the orbits of Mars and the Sun, 3I-ATLAS is carving a trajectory that reads like a poem written in physics. It currently glides at nearly 60 kilometers per second, a silent arrow slicing through the solar wind. By late October, as it dives toward its perihelion, a mere 0.36 astronomical units from the solar inferno, its velocity will crest at 68 kilometers per second. At that point, observation becomes a race against time itself. The cosmos has arranged a stroke of fortune. On October 3rd, ATLAS brushed past Mars, skimming within a quarter of the Earth-Sun distance. That moment, almost as if scripted by the universe, opened a rare geometric window. While Earth's telescopes will soon be blinded by the Sun's glare during superior conjunction on October 21st, Mars will stand perfectly positioned to take over humanity's cosmic watch. It wasn't a cosmic ray, nor a passing satellite. Frame after frame, the same luminous trace persisted aligned perfectly with ATLAS's projected motion. If confirmed, it would mark the first time an interstellar object has been imaged from another planet's surface. But for now, we wait. As 3I-ATLAS races into the sun's glare, our telescopes fall silent. The universe has turned its page, and Mars holds the next chapter. When it crossed within 2 AU, the light curve abruptly veered from mathematical expectation. Something changed, something our equations did not foresee. Perhaps new jets of sublimating ice, perhaps electrostatic discharges in the plasma sheath, or perhaps something entirely new, a kind of interstellar chemistry, awakening under solar fire. On October 2nd, the Perseverance rover on Mars captured a narrow diagonal streak across the star trails of its sky. If the universe wished to whisper, it would do so in green light. 3I-ATLAS now burns with an emerald radiance that has unsettled even the most cautious astronomers. By all conventional reasoning, this hue should not exist. The signature of green in most comets arises from carbon dimers, C2 molecules excited by ultraviolet sunlight. But spectroscopy hints at an absence, or at least a scarcity, of carbon-based volatiles. The equations tremble. Soon, between October 29th and 31st, This visitor will skim the edge of our star's domain. Will it fragment, flare, dim into oblivion? Whatever happens, physics will record every heartbeat, for this is not just observation, it is participation in a cosmic experiment that began long before we learned to look up and wonder. If the universe wished to whisper, it would do so in green light. 3I-ATLAS now burns with an emerald radiance that has unsettled even the most cautious astronomers. By all conventional reasoning, this hue should not exist. The signature of green in most comets arises from carbon dimers, C2 molecules excited by ultraviolet sunlight. But spectroscopy hints at an absence, or at least a scarcity, of carbon-based volatiles. The equations tremble. Something uncharted is sculpting this glow. When the object crossed the 2 AU threshold, its brightness began to defy prediction. It now gleams around magnitude 12, visible to backyard telescopes, yes, but glowing far more intensely than any model anticipated. Light curves once smooth and predictable have grown restless, oscillating in erratic rhythm as if the comet itself were alive, responding to the sun in ways we barely comprehend. Perhaps we are witnessing plasma resonance, where electromagnetic fields stir the ionized gases into spontaneous luminescence. Or perhaps the explanation lies deeper still, in interstellar chemistry untouched by the alchemy of any known solar system. And then came the photograph, the whisper of proof from another world. On October 2nd, NASA's Perseverance rover performed a series of long-exposure night images. Against the serene swirl of Martian stars, a narrow diagonal streak sliced across the sky, consistent across multiple frames. It was not a meteor, nor an artifact, nor a trick of cosmic rays. It matched perfectly the projected path of 3I-ATLAS as it crossed the Martian sky. For a fleeting instant, the eye of a machine built by our species half a billion kilometers away may have captured the ghostly trail of an interstellar traveler. Such coincidences border on poetry, for as Earth's telescopes prepare to fall blind on October 21st, swallowed by the sun's glare during superior conjunction, Mars now inherits the role of cosmic witness. Its orbiters, its cameras, its instruments, extensions of human curiosity, are perfectly aligned to observe what we cannot. The universe has conspired in geometry, granting us a chance to see what would otherwise be lost in light. As Atlas plunges toward its perihelion, a perilous 0.36 AU from the Sun, its fate remains uncertain. Will it fracture under thermal stress, ejecting plumes of ionized gas? Will it flare in brilliance, outshining even the most optimistic forecasts? Or will it fade, dissolving quietly back into the cosmic dark? Whatever unfolds, every photon it sheds will carry information, a clue about how interstellar material behaves under the fiercest radiation our star can offer. Beyond the spectacle lies a deeper revelation. We are witnessing the fusion of technology, geometry, and wonder. A network of machines, spread across 2 planets, has become our collective eye. Through them, we do not merely observe the cosmos, we participate in its unfolding. 3I-ATLAS reminds us that discovery is not a single event, but a dialogue, a conversation between starlight and consciousness. The universe speaks, and, across millions of kilometers, humanity listens. Will it fracture under thermal stress, ejecting plumes of ionized gas? Will it flare in brilliance, outshining even the most optimistic forecasts? Or will it fade, dissolving quietly back into the cosmic dark? Whatever unfolds, every photon it sheds will carry information, a clue about how interstellar material behaves under the fiercest radiation our star can offer. Beyond the spectacle lies a deeper revelation. We are witnessing the fusion of technology, geometry, and wonder. For the scientists awaiting this passage, it is not merely an astronomical event. It is a once-in-a-lifetime experiment orchestrated by nature itself. Every observatory, every orbiter, every instrument across 2 planets will strain to capture what happens when alien matter meets the fury of our Sunday. Will Atlas erupt in a final flare of brilliance? Will it fracture into a swarm of glittering shards, each fragment carrying a memory of its birthplace? Or will it endure, a survivor of stellar exile, continuing its cosmic pilgrimage beyond the reach of our machines? During this critical interval, Earth's telescopes remain blind, hidden behind the sun's glare, a cosmic irony of the highest order. If the universe wished to whisper, it would do so in green light. 3I-ATLAS now burns with an emerald radiance that has unsettled even the most cautious astronomers. By all conventional reasoning, this hue should not exist. The signature of green in most comets arises from carbon dimers, C2 molecules excited by ultraviolet sunlight. But spectroscopy hints at an absence, or at least a scarcity, of carbon-based volatiles. The equations tremble. Will Atlas erupt in a final flare of brilliance? Will it fracture into a swarm of glittering shards, each fragment carrying a memory of its birthplace? Or will it endure, a survivor of stellar exile, continuing its cosmic pilgrimage beyond the reach of our machines? During this critical interval, Earth's telescopes remain blind, hidden behind the sun's glare, a cosmic irony of the highest order. ESA's JUICE spacecraft, positioned deeper within the inner solar system, will extend the relay, collecting long-term data, tracing the evolution of this visitor as it recedes back into darkness. Some of that data may not reach Earth until 2026, a reminder that cosmic truth often moves at a slower pace than curiosity. But beyond the technicalities lies something profoundly human. Within a decade, we have greeted 3 interstellar visitors: Oumuamua, Borisov, and now Atlas. A network of machines spread across 2 planets has become our collective eye. Through them, we do not merely observe the cosmos, we participate in its unfolding. 3I-ATLAS reminds us that discovery is not a single event, but a dialogue, a conversation between starlight and consciousness. The universe speaks, and, across millions of kilometers, humanity listens. So as Atlas vanishes into the sun's brilliance, let us listen not with eyes, but with imagination. Somewhere in that silence, physics is speaking. And if we listen closely enough, perhaps we'll hear the next secret the universe is ready to share. In less than a decade, humanity has been visited 3 times by travelers from the deep between the stars. The first, Oumuamua, arrived in 2017, a silent shard, tumbling through sunlight, defying every definition of what a comet or asteroid should be. Then came Borisov in 2019, a more classical wanderer, trailing gas and dust like a frozen ghost from another Sunday. And now, 3I-ATLAS, the most luminous, the most mysterious of them all. Each one has rewritten a chapter of cosmic understanding. Together, they form a trilogy of revelation, a pattern that whispers of unseen abundance. The galaxy, it seems, is not empty. It is alive with motion. But what makes 3I-ATLAS unique is not merely its chemistry or trajectory. It is the timing, the precision, the orchestration of observation across worlds. For the first time in human history, 2 planets are watching the same interstellar visitor simultaneously. In less than a decade, humanity has been visited 3 times by travelers from the deep between the stars. The first, Oumuamua, arrived in 2017, a silent shard, tumbling through sunlight, defying every definition of what a comet or asteroid should be. Then came Borisov in 2019, a more classical wanderer, trailing gas and dust like a frozen ghost from another sun. And now, 3I-ATLAS, the most luminous, the most mysterious of them all. Each one has rewritten a chapter of cosmic understanding. Is it the familiar swan bands of C2, born of carbon and ultraviolet fire, or an entirely different mechanism, a photochemical ballet between plasma and dust, forged in alien chemistry? Each photon captured by Mars Express, or ExoMars TGO, carries within it a clue, a fragment of a story written in wavelengths. Soon, as Atlas rounds the sun and emerges again in December, we will compare the before and after the comet's brightness, structure, and spectral fingerprint to see how the solar furnace has sculpted it. ESA's JUICE spacecraft will continue the watch from deeper within the inner solar system. Its delayed data return, perhaps not until 2026, reminds us that science, like the cosmos, moves in cycles far grander than our impatience. Every bit of information must be verified, cross-checked, and reinterpreted in the context of what came before. Progress, in truth, is less like a thunderclap and more like the slow turning of a cosmic wheel. And yet, amid all the numbers, equations, and telemetry, there remains something ineffably human in this pursuit: the act of watching, the decision to care about a fragment of ice millions of kilometers away. 3I-ATLAS is more than a scientific target, it is a mirror. In its luminous trail, we glimpse our species' defining trait: curiosity unbounded by distance. As it vanishes once more into the dark, we are left with questions rather than answers, and that is the hallmark of genuine discovery. The universe does not yield its secrets easily. It rewards only those who listen with humility and think in centuries, not seconds. Perhaps that is the real lesson of Atlas, that even in the void, we are not alone, not because others are out there watching us, but because we are out there watching them. When 3I-ATLAS disappears behind the sun, the universe grows quiet. For several weeks, there will be no data, no images, no telemetry, only the hum of instruments waiting for a signal to return. Yet in that silence, something profound unfolds. The cosmos is still speaking, only now through patience. At 0.36 astronomical units, during its perihelion passage between October 29th and 31st, Atlas will endure forces beyond comprehension. Solar winds tearing at its surface, radiation baking its frozen nucleus, electromagnetic storms twisting its plasma tail into shapes no human eye has yet seen. Somewhere in that inferno we expect transformation, perhaps a fragmentation event, perhaps a surge of outgassing, or the sudden fading of a once luminous visitor. Whatever occurs, the universe will leave its signature upon the object's body, written in dust, gas, and geometry. Mars, still within optimal viewing range, becomes our surrogate observer. Orbiters like MAVEN, ExoMars TGO, and Mars Express record subtle changes in spectrum and brightness as the sun's gravity whips the comet's trajectory. Their instruments, sensitive enough to detect variations in ionized gas and tail density, might capture the instant when the comet's internal structure yields when alien material, born in another star's nursery, meets annihilation in our own. Meanwhile, ESA's JUICE mission, cruising deeper inside the solar system, maintains a long baseline of observation. Its sensors trace the evolution of the object's coma, the glowing envelope that surrounds its nucleus. If all goes well, the comparative data from before and after perihelion will tell us what sunlight can sculpt from interstellar matter. A natural experiment in stellar alchemy. Yet this data, constrained by communication delays and geometry, may not reach us until early 2026. Science, unlike the comet's furious pace, unfolds in glacial rhythm, and then, sometime in December, the curtain will rise again. Atlas will reappear from behind the sun, emerging like a survivor from the flames. We will measure its new luminosity, its spectral shifts, its tail's new orientation. We will ask, has it changed color? Has the mysterious green emission, the haunting glow that defied our chemistry, intensified or vanished? We will look for fragments, smaller daughters of a once-whole traveler, each tracing a slightly altered path through sunlight. But perhaps the most astonishing transformation will not belong to Atlas, it will belong to us. For in studying this distant messenger, we have glimpsed what it means to look beyond our home, to link planets in pursuit of knowledge, to synchronize curiosity across millions of kilometers. The act itself is revolutionary. When Atlas finally drifts back into interstellar night, taking its secrets with it, the data it leaves behind will seed the future doctoral theses, mission proposals, perhaps even new theories of plasma behavior or interstellar chemistry. Yet its greatest gift is subtler still. It reminds us that wonder requires endurance. The universe reveals its truths not in fireworks, but in echoes, quiet signals arriving long after the spectacle has passed. 3I-ATLAS may fade from our skies, but in the patient decoding of its light, humanity continues its oldest experiment, the one called curiosity. By December, the silence will break. 3I-ATLAS will re-emerge from behind the sun, a transformed Voyager returning from its baptism in fire. What will we see then? A survivor, reborn and radiant, or a ghost of what once was? Its path through perihelion will have rewritten its very structure. Jets of gas may have carved new fissures into its nucleus. Fragments may now travel alongside it, like children departing a burning home. Telescopes across Earth will once again awaken, sweeping the eastern dawn skies in search of a faint green pulse. Spectrographs will measure its new light signature, comparing it to the data gathered months earlier from Mars. Has the emerald emission, that haunting glow with no clear chemical source, persisted or faded into the ordinary? If it endures, we will have proof of something never before witnessed: a self-sustaining plasma phenomenon, born from interstellar chemistry untouched by our sun's familiarity. Meanwhile, ESA's JUICE mission will continue the vigil, tracking Atlas's retreat into the outer system. Its long-term monitoring will bridge the gap between observation and understanding, turning fleeting brilliance into lasting knowledge. The process will take months, even years. Data relayed, decoded, debated, refined. But beyond the science lies a simple truth. This is the moment when humanity reclaims the thread of its curiosity. We once looked up in fear, calling comets omens of chaos. Now we watch with reverence, knowing that within their light resides our own story, a story of minds that refuse to stop asking. 3I-ATLAS may fade again into the night, but its echo will remain a reminder that even the smallest glimmer in the dark can expand the boundaries of what it means to know. Each one defied prediction. Each one rewrote a rule of the cosmos. 3I-ATLAS, with its impossible glow and its delicate geometry of observation, reminds us that the universe is not a stage for certainty, but for wonder. In this age of algorithms and precision, perhaps this is the true gift of Atlas, not the data itself, but the doubt it awakens. Doubt is the engine of discovery. It humbles us, teaches us patience, and binds us again to the mystery of existence. Or is it something more profoundly engineered, a structure so complex that its behavior mimics nature, yet hints at intent? Its anomalous luminosity, its plasma coherence, its synchronized geometry across electromagnetic fields. Could these patterns be the faint fingerprints of intelligence, written in physics rather than language? We stand at a crossroads between wonder and skepticism. Every observation we make, every photon measured, every spectrum recorded forces us to confront the same question. How much of the universe is alive with purpose, and how much is simply the poetry of physics itself? Perhaps, in studying Atlas, we are not just analyzing an object, but glimpsing our own reflection, the curiosity that defines us as a species willing to ask impossible questions. For the scientists awaiting this passage, it is not merely an astronomical event, it is a once-in-a-lifetime experiment orchestrated by nature itself. Every observatory, every orbiter, every instrument across 2 planets will strain to capture what happens when alien matter meets the fury of our sun.